Hello, and good morning, good afternoon, or good evening, depending upon where in the world you're joining us from. My name is Gray Slough, and on behalf of TA Instruments, I'd like to welcome you and thank you for joining us for this TA Instruments product webinar introducing the Discovery X3 DSC. Today's speaker is Dr. Jason Sanga. Dr. Sanga is currently the product manager for the thermal analysis and thermal conductivity product lines at TA Instruments. Jason joined TA in 2006 after completing his doctorate program in materials science and engineering at Iowa State University. Jason started out his career at TA in the applications lab, teaching the theory and applications lectures, instruments hand-on courses, and providing customer and sales support for the thermal analysis techniques. As product manager, Jason and his team worked to define and coordinate the future of the thermal analysis and thermal conductivity product lines at TA. The title of Jason's webinar today is Discover the Possibilities with the new Multi-Sample Discovery X3 Differential Scanning Calorimeter. During the webinar, you can submit questions, and after the talk, we will answer as many as possible. I would also like to direct everyone's attention to the folder icon in the lower right-hand corner of your screen. If you click on that icon, you will find web links and PDFs of interest available to you. With that, I'm going to hand it off to Jason. Jason?
Thank you, Gray. Appreciate that introduction. I too welcome everybody. I'll say good morning, good afternoon, and good evening to all the folks that are out there as well. I'm glad that you were able to join us for this webinar today, and glad to, pretty excited to be able to introduce this new product offering from TA Instruments. You know, we're really, it's the newest addition to really an already incredible Discovery series suite, you know, including the Discovery DMA 850, TMA 450, the SBT 650, as well as our Discovery DSC and TGA product line. So, you know, really excited to introduce you all to this newest addition, the Discovery X3 DSC. You know, the X3 DSC it's a multi-sample Discovery DSC, multi-sample DSC. It is really you know, something that we're really excited about. It's going to provide your lab an amazing addition to your arsenal of, you know, material research and testing. It delivers, you know, high level performance from heat flow, and it can do so on three samples simultaneously. So really a new revolutionary technique in DSC measurements. You know, and really on the outside, obviously 3 samples tested simultaneously. You say, well, you know, it's going to save me you know, gas consumables. It's going to save me lab space. It's going to be able to crank out samples testing at a much faster pace, and that's great. But the possibilities that exist with the X3 DSC are really, you know, quite broad. You know, there's no reason to compromise on, you know, on testing with the X3 DSC. You don't have to choose between you know, throughput and the right method. So, you know, increased confidence is obviously you know, a key to the X3 DSC. You know, providing a high level performance from temperature and enthalpy accuracy, but generating that same level of performance on 3 samples simultaneously gives you the opportunity to get statistical data sets. So you can collect high level data, a high degree of certainty with those results 3 times faster. You also have opportunities for real-time validation. You know, that could be a qualitative comparison between, you know, materials that you know and materials that you might not know. But obviously, the ability to test against standards internal or external standards simultaneously. It gives you real-time feedback to your materials, to your research, to your development path, and then really providing the opportunity to have deeper insight into the materials and materials you're researching or the materials you're investigating. Modulated DSC, if you're familiar with it, is potentially a slow experiment. It potentially could tie up a DSC for 90 minutes or a few hours or longer. So sometimes as samples build up in our lab, there becomes this backlog, and so we compromise the right method for sample throughput. So in this, the DSC, the X3 DSC provides us that opportunity to really dig in deeper, learn more about the materials, learn more about, be able to characterize materials at a much higher degree than we would, maybe traditionally reserve ourselves for a standard single cell system. And so we're going to really kind of work our way through this. It's a full package for, I'll say a full package of productivity tools. And productivity is going to be defined differently in different labs. If you're a QC lab and you need high sample throughput, we have the tools for you. If you're really trying to investigate, you're in an R&D lab and you're trying to investigate your materials a little bit deeper, maybe we're reluctant to do so because of the time it took, this is going to provide tools for you as well. So we're going to explore the possibilities of the X3 DSC. It's built upon a similar or same fusion cell design that we utilize in our single sample sensors. Our Discovery DSC platform was the introduction of the fusion cell, and clearly this isn't the same cell. We have 4 pedestals, 3 samples, and a reference pedestal, but it's built upon the same independent heat flow measurement. So we have 3 independent sample measurements, as well as the T0 thermocouple that resides in the center of that cell, thus providing us an independent temperature measurement, and really it provides us a much higher degree of results, heat flow results, temperature, enthalpy accuracy. But it's not just the hardware. Obviously, we are incorporating it's an adaptation or a similar T0 heat flow equation to this particular design. But as we've discussed with the previous Discovery DSC, as well as some prior Q-series DSCs, the T4 heat flow equation collecting is significantly more detailed than a traditional heat flow measurement. We take in information regarding the cell capacitance and resistances. In the X3, obviously, we're taking in information regarding the capacitance and resistances of each sensor individually. So we have a characterization of each of those sensors so that your measurement is a measurement of your results are a measurement of the sample and what it is doing, rather than having any impact on any impact from the instrument. And so you should already gain some level of confidence in the results, because we've eliminated that instrument impact. But ultimately, the overall design of the X3 provides the same level of baseline stability, repeatability, baseline flatness that you should expect on any research grade DSC. Certainly provides us opportunities to get the right answer for every measurement for every sensor. The flat baselines, the reproducible baselines here in this example gives us the opportunity to see a small glass transition, a 19 microwatt step change of a 100 microgram sample of polystyrene. So without having this attention to detail on both the design and an understanding of the instrument impact, we wouldn't be able to confidently pull out a small glass transition like that in the polystyrene example. And so, really, the hardware design is built in a way that should provide a level of confidence and repeatability, and that allows us then the opportunity to explore our applications. It allows us an opportunity to see where the X3 provides benefit. And I talked about increased confidence in our results. In this example, it's a single run, and yet we have 3 data sets of 3 independent data sets. In this case, it's phenacidin with some impurities, and so we can see that we have 2, let's call them unknown materials, or 2 materials with a level of impurity, compared to a sample that has is essentially or defined as a pure material, pure phenacidin. So here, in a single experiment, even if you didn't want to go down the quantitative route, you can clearly see that there's differences between these materials. So this is a quick run, and we have a very clear picture, a very very easy direct comparison of 3 materials that maybe we know, maybe we don't know, but it adds that level of increased confidence in our results. If we look at another example here, this particular example is magnesium stearate and aspirin, and then a mixture of the 2. Magnesium stearate is commonly used as a lubricant in pharmaceutical materials, but it could be any 2 materials, but investigating the compatibility or incompatibility between materials typically requires some understanding of what the raw materials are going to do independent of the mixture. And so, here we don't have to run 3 separate experiments to get an idea that this mixture between the magnesium stearate and the aspirin are incompatible, thus showing us 2 separate peaks in the heat flow rather than 2 independent peaks associated with the magnesium stearate and the aspirin. But this could, obviously, this example is, related to a pharmaceutical material, but you could certainly go from, 3 complete unknown samples to full confidence in a single test, instead of, having to run 3 tests independent in sequential order, getting understanding. So there's certainly, like I said, there's different definitions of productivity, and if trying to understand, compatibility or incompatibility or stability, is key for you, then being able to run, maybe it's various concentrations of mixtures, maybe it's independent components versus a mixture of them. But any of those really lead us down the road that we have the ability to get more confidence in our results, what we expect, much faster. But as I alluded to earlier, there are times where we certainly want to be able to dig in deeper and understand the material structure at a deeper level. And in the fast-paced world that we live in, it's very possible that that our critical tasks are to be able to test a lot of different materials rather than spend a lot of time digging in deeper to understand the structure, investigate the materials at a higher level, or dig deeper gain more insight into the material. So in this particular case, you can certainly run 3 sequential modulated experiments. Each of them in this case would take you upwards of 90 minutes with this quasi-isothermal modulated experiment. But in this one, if you translate this task over to the X3 DSC, we've been able to gather information about how the structure changes based off of the pan type for these 3 samples with a single run. So this is information that you could certainly gather with a standards DSC, but it would take you much longer to do so. And so again, this is another example where you are going to build confidence, but you're also providing an opportunity to investigate the materials at a much deeper level. The X3 makes these longer modulated experiments certainly more practical, and certainly fit into most schedules much easier. Real-time validation. We can certainly say in this, so in this example, we're looking at some cross-linking materials. It's epoxy materials. This case, it's uncured versus 15 minutes versus 60 minutes. This experiment, allows us, the X3 allows us to take each of those materials at a time zero, run them all at the same time. So there's no question about whether those materials cured while waiting to be tested on the DSC, whether there was some cross-linking taking place, whether there was some material change as we waited to make that measurement. Obviously, not all materials are going to be changing as a function of time, but certainly, here where we're looking at a chemical reaction has some kinetic component to this. So the more we wait, the more time, the more different it may be when we eventually get an opportunity to run it in the DSC, unless you have 3 DSCs on the bench and you can run them all at the same time. This example is, this is a pristine example of collecting 3 samples that may change over time, examining them all in a single test, all from time zero. But it could be that materials that have gone through a different cure program may have different cure states. There may be more residual cure in one versus another, and so it could be a function of a quality control. It could be it could be a failure analysis and type of investigation. Running a known good material with some an unknown bad material. But it could also be in process optimization. If you're trying to understand different cure profiles, you could have a selection, a collection of different materials that have undergone different cure profiles and be able to investigate those a little bit deeper. So all of that, again, collected in a single run. But you could also take that a step further and say, well, I just want to be able to collect some meaningful statistical analysis of materials that I know are good. If you run a single sample, there's a potential that it may be an outlier. So running 2, 3, 4, or more samples, is obviously going to provide a much better representation of the material as a whole, rather than relying on a single measurement. So again, multiple measurements in a single cell require multiple tests, and in sequential order, they take much more time. So here, the opportunity to run 3 samples in a single run, really does provide a significant opportunity to, have confidence in the results that you're gathering, as well as, save that time that you would have otherwise spent, testing more and more samples on the DSC. But again, another, kind of a QC opportunity. I mean, there's a lot of crossover, obviously, between different types of applications, and so that's why I said that, the possibilities of the X3 in different areas of research and quality control and failure analysis, or wherever you might be looking, there is certainly a lot of possibilities there. You look at this particular example, we have PET crystallization on cooling. These are 3 different samples. Maybe they're different manufacturers, maybe they have different additives, maybe they have different nucleating agents. But clearly they have different crystallization peaks as we cool them down. A single test in this case can provide us information about how your material compares to a competitive material. So there's a reverse engineering aspect to it. It could be that that you want to look at materials across the surface of a film or a block, if there's any kind of homogeneity issues, running a single sample probably isn't going to give you the full picture of your material. So again, running a single test can give you, an idea or a very clear picture of how the material, what the material might be, what the structure may be from one side to the other side, from the top to the bottom, from the front to the back. And so, again, it's a single test, but it provides you a much clearer picture of what you're dealing with, what you've got in your hands, rather than, a single measurement where, if it is an outlier, then you're wrong with your conclusion, unless you run more samples to be able to verify that or validate that. So there's certainly a lot of critical pieces of information that can be extracted from the X3 DSC that could potentially be tested on a single sample cell, but you're going to spend 3 times longer to collect that same information. So that is certainly where a lot of the possibilities exist. From a sample testing perspective. But like I said, we're going to talk about this is the full package. Obviously, you're running samples 3 times faster. You need the tools to be able to make up samples 3 times faster and load them into the cell 3 times faster. And so, the reliability of the automation and the automation aspects of the DSC provides opportunity for 24/7 operation. There's 54 positions on the autosampler tray. The trays are swappable. In Trios, the queues are endless. You have the opportunity to continue to load trays and keep the X3 running 24/7 if need be. There are also opportunities for automated calibration and verification routines that can be set up. So most of these tools are designed again to provide the researcher more time spent researching rather than time spent loading samples into a DSC or worrying about whether the samples were loaded properly or whether the one touch away touchscreen display again is the one touch away.
Hi, everyone. Sorry, sounds like Jason may be having some issues here with his audio. So this is Gray again. So I'm going to pop in here and continue. Hopefully, Jason will be able to join us again. So talking about the one touch away touchscreen here. So the touchscreen has a lot of functionality on the instrument. As you can see here, kind of done a little accordion style thing that says shows there's a number of functionality that's available at your fingertips. So you can control the auto sampler from this touch screen. You can check the method that's running. You can do most importantly, you can do the calibration of the instrument. So I think Jason is back here. So Jason, you want to take back over again?
I am back. Yep. Sorry about that, everybody. So, Gray touched upon the one touch away touchscreen. Obviously gives you functionality as you're standing, in front of the instrument. Provides opportunity for you to interact with the instrument if need be, and see where see the state of the instrument. So mostly just to keep the process going. But like I said, the tools that there's a package of tools that are going to allow you to really maintain that level of productivity and maintain that level of confidence in the results. The tools for sample prep, like I said, you're making samples much faster because you need more samples to accommodate the X3 DSC. So, the T0 press it creates an opportunity to seal pans, encapsulate samples into your pans, with relative ease. Your hermetic seals are going to be truly hermetically sealed, and that you have confidence in the quality of that sealing process. The T0 pans are designed to maintain, perfect flatness, so that there's great contact between your sample and your pans and your sensors. So again, you're going to achieve, high degree of sensitivity, high degree of resolution, because those pans exist and are designed that way. But obviously, loading samples into pans and cutting and preparing samples is critical, to make sure that we maintain that efficiency in our production. So obviously we have a sample prep toolkit. Makes it very easy for us to load small quantities of powders into pans, as well as a new sample cutting kit that gives the ability to very easily punch out films or cut chunks of samples or cut squares, and so they're designed for the right size for the pans, and make that sort of streamline that process of streamline the process of sample prep, so that we can again spend more time examining the data, looking at the data, understanding the material, and less time in front of our prep station or in front of our DSC loading pans into our system. But it's not just hardware that really makes this an amazing tool. Obviously, Trios has been around the Discovery Suite for some time. It controls multiple instruments, whether it be a DSC, DHR, TGA, rheology, whatever the case might be. If you have comfort level with one particular setup, you're going to have the same level of comfort on the X3. And obviously, there's a lot of automated routines that can be scheduled, automated report generation that really help streamline that process as well. And obviously, Trios Guardian is an option available for Trios that would provide you an electronic signature or some level of compliance if that's necessary. So there's certainly a lot of flexibility, a lot of availability within the Trios platform. So like I said, automated report generation, whether it's creating Excel documents, control charts, PowerPoints, whether you need data extracted or exported into a LIMS system. Again, Trios has plenty of functionality for you. And yeah, there's obviously an array of analysis features that exist for all of Trios. There shouldn't be an analysis technique within Trios that you wouldn't be able to find as it pertains to the DSC, as well as some of the advanced analysis capabilities such as kinetic modeling, advanced custom analysis, repeat analysis, control charts, and a new feature really that can maximize your sample throughput. I mean, we've talked about how loading samples, we want to streamline the process of preparing samples, loading them, having them automatically loaded into the cell, keep that system going. But clearly there's a lot of data that's generated outside of that. And so, working through creating, going through analyses on each one of those data sets, generating a report, being able to provide something to somebody else with some results, collecting control charts, tracking, the data that you might have on a particular material. Those can all now be automated to some degree. Batch processing gives us opportunities to apply, different types of analyses, apply those plots to reports and extract those results that we've collected into controlled charts. And this can be done in one of two ways. It can be done on a set of stored collection of files. So, if you have a folder or you've collected a bunch of data, you weren't really sure what to do with it at the time, but now you know that you want to apply a particular analysis template, you want to extract all the information from that particular group of files, you now can take that all in one shot, in one go, and work through an entire folder or entire group of files. So it's a very quick and easy and streamlined process there. You also have the opportunity to have any of these applied to a single run. So at the end of every run, you now have a post-test analysis routine that could be run on that sample, or generate reports. Extract the plots and present them in a way that you might present them to someone else, as well as send those results to a control chart. So there's numerous possibilities when it comes to integrating the software and batch processing into the X3 work stream. And as some of you may know already with some of our other Discovery Series equipment, the X3 is also included in the only 5-year cell warranty. So we want you to have confidence in the results, and we want you to have the peace of mind that TA Instruments has your back, that we have a high level of confidence in our instruments, and we want you to have that same level of confidence. So the 5-year warranty really should give you that peace of mind that something happens to the cell that we're going to be able to for whatever reason, whatever happens to the cell, that you're going to be able to keep your system up and running and your productivity level fairly high. And so that's really the full package of this X3 DSC. Like I said, it is a productivity tool, but like I said, productivity is going to be defined differently in different areas of material testing, whether it's a QC lab, whether it's a failure analysis lab, whether it's an R&D lab. Productivity will be different. But the level of performance that the X3 will provide you and the level of confidence that you would have in the results should give you the opportunity and the possibility of collecting real good, accurate, reliable data, and again be able to really dig in deeper, looking at material structure, looking at compatibility and instability, looking at shelf life, looking at any number of things. The X3 is going to give you an extraordinary level of possibilities, because of the fact that you're not constrained by running one sample at a time. So with that, I will. I thank you for your attention. And before I start into some questions here, I just want to give everybody a heads up that we have a lot of different events taking place over the next couple of weeks here. We have a couple of other more applications-driven webinars next week for pharmaceutical characterization on the X3, as well as polymer characterization. So we'll dig in a little bit deeper in each one of those particular webinars, look at a lot more data, understand how understand the X3 from an applications standpoint, as well as some events that we have related to the new DHR, the new HR series, and some live demos and so forth. So make sure that you check out the virtual trade shows website that we have set up. We can get a lot more detail, and then obviously make sure that you check out tainstruments.com for other webinars, tech tips. There's a lot of material there to investigate. So and if in doubt, reach out to your local TRs, and I'm sure that they'll be able to assist you with any other further questions you might have. But at this point, I thank you for your time and your attention, and I'll take any questions that you guys might have.
Okay, thanks, Jason, for that great presentation. So yeah, we'll now address some of the questions that were submitted. First, I do want to let everyone know that this webinar will be archived and available later for replay. And again, I encourage you to also refer to apps notes that are available in the resources section and on our website. So yes, we did have a number of questions submitted during your presentation, Jason. So first question is, do you have to run 3 samples at a time in this instrument?
Certainly not. It's obviously designed to maximize the number of samples, but no. I mean, it can certainly be run as a single sample system if need be. The one great thing about the T0 sensor design is that each sensor is independent of one another. So you're not necessarily going to impact the performance of that sensor just because you're running 1, 2, or nothing on a particular sensor. So no, certainly not. There's no reason why you can't run a single sample at any point in time.
Okay, thanks. Could you comment on the sensitivity of the X3 versus, say, a 2500 DSC?
Well, sensitivity from a specs perspective is probably very similar to 2500. The spec for sensitivity is typically related to the underlying noise. I'll say that it's likely equally as sensitive to the same transitions and the same events that might show up in a 2500. Sensitivity from a practical standpoint is really a matter of being able to detect and potentially quantify a transition. And so having the fusion cell and a lot of the technological advancements that go into the fusion cell provide a very flat baseline, very repeatable baseline, and ultimately low noise so there's virtually no instrument impact. And so when you have a nice flat baseline, you can obviously see transitions much easier. If your baseline had a lot of curvature, a lot of shape to it, if you were subtracting baselines, there's always the potential that you're going to end up with some anomaly that exists, or with the curvature example, the potential that you're not going to be able to really clearly see maybe a small glass transition because it gets lost in the curvature of the baseline. So yeah, certainly the sensitivity should be equal to the 2500. From a specs perspective, I think that it's equivalent to a 2500.
Okay, thanks. The next question deals with the press. It says, is the sample press compatible with previous pan press sets? Do the new colors correspond to the old colors?
Yeah, so this is I believe so. I depends on how far back you go, I guess. This T0 press is the same T0 press that TA Instruments has been providing for a number of years now. The color schemes are designed to help you match up the appropriate pan type with the appropriate die set that go along with this press. The press isn't specifically new to the X3, but the press will seal. The press does have the ability to seal T0 pans, which are typically the blue die sets. But you also have blue die sets, black die sets, You also have the opportunity to seal the old style hermetic pans with the white die sets and the old style crimped pans with the green die set, as well as high volume pans and TGA sealed pans. And so, yeah, so the press is designed to accommodate all the pans that we sell for the DSC, minus maybe the high pressure pans, which require a whole different setup. So, hope that answers your question.
Okay, thank you. Next question is the cell in the X3 a single cell or multiple cells for each sensor?
I don't quite understand the question. It's a single temperature environment, I guess I'll put it that way. It is only slightly larger than the silver block is only slightly larger in diameter than a standard single cell design, and it's just slightly larger to accommodate this cloverleaf sensor design. So so all four of those sensors, and ultimately all three of the samples that are tested in there, are going to be experiencing the same temperature, the same time, the same rate, the same purge gas. So you still are enclosing all of these samples within a single temperature environment. Obviously the response that you're getting from each of these sensors is totally independent of one another. There is obviously a differential to the reference, but the T4 heat flow equation, combined with the T0 calibration and the T0 thermocouple, all of the design facets that go into that particular the T0 cell provide opportunities to measure the heat flow independent on each one of those sensors in that cell block. So it is not a system where you have three independent temperature environments connected up to the DSC. So from the outside looking in, it looks, if you didn't walk up to the cell, it would look exactly like a standard cell DSC.
Okay, thank you. Yeah, I think that's what the question was aiming at. So thank you.
Okay. All right.
And then there's a question about calibration of this DSC. So it says, does each sample cell need to be calibrated separately? I'm assuming that means does each sensor.
So the calibration routine. Yeah. So the calibration routine that we have had in place for the Q series as well as the Discovery series DSCs required an empty cell run as well as a Sapphire test, and we call it calibration, but ultimately what you're trying to do is you're trying to measure the capacitance and the resistance on each one of those sensors. So even in a single cell system, you've got a Sapphire on the reference and a Sapphire on the sample. In the X3's case, you have you're measuring the response of empty cells or empty sensors or bare sensors, as well as throwing a Sapphire on each one of those sensors and making a measurement. Again, everything that is done with this system is no different than, in terms of test time, would be no different than you would have in a single sample system. So the length of time for a T0 calibration is the same here as it, over the same temperature range as it would be for a single sample sensor. We're just collecting that much more information about each one of the sensors and incorporating all of those into independent T4 equations to be able to extract heat flow independent on each one of those sensors. So, and when you're looking at temperature and enthalpy calibrations, it's again the same thing. You're going to run 3 pans with indium versus just a single pan of indium, and so again, one run, and you're calibrating all 3 sensors at the same time.
Okay, thanks. I think we have time for one more question here.
Okay.
So this is a question from someone who has, I believe, a discovery or a queue, and says, can we run one sensor with T1 mode and the other with T4P mode at the same time?
I'll say that the answer is no. I mean, in some of our other DSCs, we had an opportunity to kind of switch through the different heat flows. So if you had a 2500, I mean, you could run in a T1 mode or the T4P mode. Because of the way this cell is designed, there really is only a specific heat flow for this system. So there's no changing, there's no selecting. You're going to get all the advantages of the T0 heat flow, but there's also because there are 3 samples in this 4 pans rather in this cell at the same time. You do have to enter in the pan masses for each of those, and so it is, like I said, it is similar to the single sample cells from the T4 heat flow equation, but it is a slight modification from that to be able to understand and adapt to having multiple samples within the same enclosure versus just a single sample in the same enclosure. So, no, there is technically no T1. In this particular case, there's technically no T4 and no T4P. It is the X3 heat flow. We call it the enhanced heat flow signal from the X3. So I hope that answers the question, I guess.
All right. Thanks, Jason. And with that, I'll unfortunately have to bring the question and answer session to a close. Any questions that we didn't answer, we will answer by email as soon as we can. I want to thank everyone again for their attendance. And again, to reinforce what Jason spoke about at the end of his talk, please stay tuned for more webinars from TA Instruments. And that includes tomorrow's product webinar with Alina Latshaw, which is introducing the new Discovery hybrid rheometers at 11 a.m. Eastern US time. Thank you, and we look forward to you joining us again in the future. Goodbye.